Hi, this is javinkharod, a chemical engineer by profession, going to continue most important topic of the refinery today, continuous catalytic regeneration. Now, what is continuous catalytic regeneration? The catalyst regeneration process allows continuous regeneration of controlled quantity of the catalyst and use reforming application by refinery for the application are critical process and therefore need extremely reliable to minimize costly downtime. Now, what is method of regeneration catalyst? The catalyst regeneration, the coke burning off, the important process, all of the commercial process, the coke burning off is highly exothermic and the inlet temperature, the catalyst regeneration is high as required by need of fast and complete regeneration. Now, controlling efficiency in continuous catalytic regeneration, maximize catalyst lifespan, minimize thermal damage and affect overall quality and quantity of the final product. Now, continuous catalytic regeneration is the part catalytic reforming process in a refinery where hydrogen and naphtha feed they are reacted to create desired product. Catalyst use in the regeneration, the continuous flowing through reactor and then regenerated, the efficiency, the regeneration process, impact, yield and quality of the end product. Now, the experience as far as the process critical measurement, oxygen and moisture, the oxygen developed dedicated oxygen analyzer in conjunction with UOP, continuous catalytic regeneration process achieve required low level oxygen measurement during the critical regeneration cycle. For moisture, the provide high sensitive instrument, the process, the accurate reliable result that are unaffected, reformer, contaminant such as compressor oil and high boiling point hydrocarbon. Now, oxygen monitoring. During regeneration cycle, coke deposition, they are removed the catalyst by oxidation, measuring oxygen content, stage critical, minimize thermal damage, maximize catalyst lifespan, optimize process efficiency. Now, hydrogen recycle gas. The proper moisture balance, the feedstock hydrogen recycle stream must be maintained, optimize product yield and catalyst life, accurate, rapid result, recycle despite wide variation moisture content. Now, catalytic reform is a chemical process used to convert petroleum refinery, naphtha distilled, the crude oil typically low octane rating have high octane liquid product called reformate. They are premium blending stock for the high octane gasoline. The process convert low octane linear hydrocarbon paraffin into branch alkane isoparaffin and cyclic naphthane. They are the partially dehydrogenated. They produce high octane aromatic hydrocarbon. The dehydrogenation also produces significant amount byproduct hydrogen gas which is fed. The refinery process such as hydrocracking or side reaction hydrogenolysis to produce light hydrocarbon, lower value methane, ethane, propane and butane. In addition, gasoline blending stock, reformate, main sources, aromatic bulk chemical such as benzene, toluene, xylene, ethyl benzene, which have diverse uses. Most important raw material, the conversion into plastic. However, benzene content reformate make it carcinogen, which has led government regulation effectively require further processing to reduce its benzene content. Now process quite different. Not to consume and confuse the catalytic steam reforming process industrially the produced products such as hydrogen, ammonia, method from natural gas, naphtha, petroleum derived feedstock. Note, process is confused with various other catalytic reforming process, the methanol, biomass derived feedstock to produce hydrogen, fuel cell and other uses. These are two main classes into catalyze and catalyst utilize reforming process fall that are first one is supported noble metal, second one is non-noble transmission metal. Now best catalyst synthesis gas utilization, various procedure has been subjected to several research. Rhodium, ruthenium, platinum, as well as palladium, iridium catalysts have all been subjected in-depth study hydrogen production, catalytic, thermal decomposition, the dry reforming catalyst, noble metal used to catalyst. They are much more effective, other less susceptible to deactivation, the carbon production and oxidation, but because they are more expensive, cost near around 100 to 150 times more than nickel catalysts. They are less frequently used in industrial use. Catalysts depend nickel, they are increasing, often utilized. However, due to carbon accumulation, their resilience is low. The most crucible issue, the methane reforming, particular dry reforming, is the suppression, the carbon deposition, non-noble metal catalysts, increasing the surface basicity of catalysts, regulating particle size, active ingredient, two technique used to prevent carbon foam deposition, the improvement of the metal support interaction, the creation of solid solution and plasma processes. There are only few strategies have been developed to manage metal particle sizes, the surface basicity and catalyst was increased using basic metal oxide support promoter increases. The catalyst was increases using basic metal oxide support promoter increases process and consequences of the work several author has improved overall efficiency, environmental performance. Now most common use catalytic reforming has reactor, each fixed back catalyst, all the catalysts regenerated during the continuous catalytic regeneration shutdown which occur approximate 6 to 24 hours. Such unit reformed semi-regenerative catalyst reformer process. Now some of catalytic reforming unit, extra spare and swing reactor, each reactor individually isolated. One reactor can undergoing in situ regeneration, which other reactor they are in operation. When reactor is regenerated, replace another reactor which is turned isolate so that it can be regenerated. Such unit reform cyclic catalytic reformer. They are not very common. Cyclic catalytic reformer serve extended period between requirement shutdown. The latest and most modern type catalytic reformer, they are continuous catalytic regeneration reformer. Such unit defined by continuous in situ regeneration part, the catalyst special regeneration and continuous addition, regenerated catalyst operating reactor as two continuous catalytic reactor version available, UOP catalytic continuous reactor platform process and XN octanizing process. The installation use continuous catalytic reactor unit repeatedly increases. Many of catalytic reforming unit were non-regenerative. They did not perform the catalyst regeneration. Instead needed aged catalyst replaced fresh catalyst and aged catalyst was shipped the catalyst manufacturer very regenerated recover platinum content of the aged catalyst. Very few catalytic reformer currently operation non-regenerative. Now catalyst and mechanism. Most catalytic reforming catalysts contain platinum, rhenium, silica alumina support base. The sum of contain both platinum and rhenium. Fresh catalyst is chlorinated prior to use. The noble metal, platinum and rhenium, they are considered catalyst site for the dehydrogenation reaction. The chlorinated alumina provide acid site needed isomerization, cyclization and hydrocracking reaction. The biggest care has the exercise during chlorination. Indeed, if not chlorinated or insufficient chlorinated, the platinum, rhenium catalyst would be reduced almost immediately. Metallic state, hydrogen, the vapor phase. On the other hand, excessive chlorination could depress the excessive activity of the catalyst. The effectiveness of catalyst is a semi-regenerative catalyst reformer reduced over time during operation. The carbonaceous coke deposition and chloride loss activity, the catalyst can periodically regenerated or restored in situ high temperature oxidation and coke foam chlorination. As stated earlier, the semi-regenerative catalyst reformer, they are regenerated about 6 to 24 months the higher severity of reacting condition, temperature, higher the octane, the produce is reformed. Also, shorter duration, cycle between two regeneration, catalyst cycle duration is also very dependent on quality feedstock. However, independently of the crude oil used to refinery, all catalysts require maximum final boiling point of naphtha feedstock 180 degree centigrade. Normally catalyst can regenerate it perhaps 3 or 4 times. Therefore, it must be returned, manufacture reclamation of the valuable platinum or rhenium content. Now, numerous hydrocarbon conversion process widely used to alter structure and property hydrocarbon string. Such process include isomerization, straight chain, paraffinic or olefinic hydrocarbon, more highly branched hydrocarbon dehydrogenation, producing olefinic aromatic compound, reforming produce, aromatic motor fuel, alkylation produce, commodity chemical, motor fuel, transalkylation and other. Many such processes use catalysts promote hydrocarbon conversion reaction. These catalysts tend to deactivate the variety reaction include deposition, carbonaceous material, coke upon catalyst, sintering, agglomeration or poisoning catalyst metal on catalyst, loss of catalyst metal promoter such as halogen. Consequently, catalysts are typically rectified in a process called regeneration. Reactivation include example removing coke catalyst by burning, redispersing catalyst metal such as platinum, catalyst oxidizing catalyst metal, reducing such catalyst metal, replenishing catalyst promoter, chloride on catalyst and during the catalyst, for example, regenerating spent catalyst. Now some regeneration process. Catalyst is past reaction zone, a regeneration zone and may include one zone, catalyst heating zone, a chlorination zone, catalyst drying zone and catalyst cooling zone where the catalysts include coke burning, coke from catalyst burn zone, increasing temperature, the catalyst in catalyst heating zone, dispersing the metal on catalyst chlorination zone, replacing chloride, catalyst or both, dyeing catalyst, catalytic drying zone, cooling the catalyst is a catalyst cooling zone. However, some of regeneration process system may require higher temperature, achieve optimum desired temperature, chlorination zone. Therefore, it will be desirable to provide process allow desirable temperature or range, chlorination zone, achieve. Additional, some of regeneration process require a higher temperature to achieve a optimum drying zone temperature. Therefore, they will be desirable to provide a process allow desired temperature drying zone to be achieved. Furthermore, some of regeneration process system they are electric heater and oxygen supply system. Therefore, it will be desirable to provide a process allow regeneration process run with wider range of catalyst coke value. Additional, it will be desirable to provide a process allow for the proper amount chloride and introduce dispersed metal catalyst without increasing amount chloride. Regenerated catalyst otherwise would be desirable have processed the chloride level of the catalyst decouple chlorine with dispersion. The process can operate lower level chloride while achieve sufficient metal dispersion. Furthermore, some of current design allow metal dispersed in a chlorination zone, drying zone using some of mode operation. However, especially black 1 mode catalyst has high level coke only nitrogen injected into this zone. Additional, no chloride injected into regenerator. The operation condition prohibit metal include platinum dispersion, black 1 mode, resulting decline catalyst performance, C5 plus yield, hydrogen product yield and lower activity. Furthermore, during operation mode, coke slippage and slightly higher coke catalyst passing into chlorination zone may result poor metal dispersion, catalyst damage, catalyst fine regeneration, equipment fouling. They are shortened process, turn around internal leading to potential unit shutdown, resulting loss of production in reforming unit. Therefore, they would be desirable. The process, the metal dispersion occur during various operation mode, and it would be desirable to provide a system into increasing the coke burn, avoid coke catalyst from burning chlorinated zone. Therefore, there remains a need effective, efficient process for regeneration catalysis. The present invention include provide effective and efficient process for regenerating catalysts. According to one of aspect, the present invention provide a process, the continuous regeneration catalyst, which catalysts pass from reaction zone and regeneration zone, where regeneration zone include at least one zone to remove coke from catalyst. The catalyst is the cooled catalyst cooling zone. After a catalyst exit one zone, while catalyst passes through chloride and metal dispersed on the catalyst chloride chlorination zone. After the catalyst has left catalyst cooling zone, it is contemplate that all chlorinated zone disperse below one zone, so that chloride in chlorination zone allow upward throughout the one zone. It is contemplate all the sum of the coordinate cooling zone catalyst is cooled temperature least 100 degrees centigrade lower than temperature catalyst. As the catalyst enter the chlorination zone, additional alternate the cooling zone catalyst cooled temperature between approximate 350 degrees centigrade to 70 degrees centigrade. Okay guys, this is up to continuous catalytic reactor. I hope you get sufficient knowledge after watching my video. Next chapter we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself, and we wishes you a very happy Sunday.